We're going to talk about simplifying lots of different types of expressions. We're going to look at some different symbols that we use. We're going to do some order of operation kind of stuff as well. So we're just kind of looking at, what would I need to do in the order that I need to do it in is the biggest thing. Before we get into order of operations, though, we're going to talk about some of the symbols that we might see as we kind of go throughout the order of operations. Two of the biggest symbols that we're going to see is exponents, okay? Exponents of all kinds. And then obviously we're going to see some like square roots, cube roots, which would be kind of like the opposite of squaring and cubing something. And we're not just going to see squaring today. We're going to see cubing, maybe the fourth root, or raising something to the fourth power. So we're going to see a lot of different things. So first thing we're going to start with is some exponents. Okay, and you are able to use your calculator, so that's a good thing, because a lot of these are going to be ones that not necessarily making you do mental math, but knowing what it means and what we do when we do take something and raise it to a power. So starting off, if I had -2 to the fourth power. Okay, one thing that's going to be extremely important today is where is the exponent and do we have parentheses or not? And I'm going to show you the difference between having parentheses versus not having parentheses, and that is going to change our solution in some cases. So in this case, and not that we have to write it out like this every time, but just understanding what is going on here. Whenever we have an exponent of 4, what we're really saying is we're taking -2 times itself 4 times. Okay? If you're going to put this into your calculator, then the button that you are looking for, there's usually 2 of them. One of them kind of looks like, I call it the caret button, because it kind of looks like a carrot. In some cases, it's either y to the x or x to the y. Those are your exponent buttons. Because typically most calculators don't have an exponent of 4. You probably have a squared button. Some calculators have a cubed button, but most calculators don't have a fourth button. Because we don't typically raise to the fourth very often. Okay, we do squares a lot, we do cubes some, but we don't usually raise to the fourth power. So if we multiply all this out, -2 times -2 would be 4, -2 times -2 would be 4, and then 4 times 4 would just be 16. Okay. And once again, you could try putting it into the calculator, make sure you're getting 16, make sure you know how to type that into your calculator, and if you're not sure where that button's at, let me know, and I can help you find that. Okay. Now here's a big difference. Okay. If I do not put parentheses around the -2, then this would be the same thing as only the 2 being raised to the power. So it's really like the negative being on the outside. The negative is not being raised to the power. And that's a really big difference because in this case then, we're not keeping the negative with it every single time. We're keeping the negative out in front, multiplying the 2's together, and then what's going to happen here is we're going to get a little bit different answer. And so here we're going to get -16. So that's probably the biggest thing, is you got to be careful about how you put this into your calculator. Okay? Is the whole thing in parentheses versus do I just want the 2 being raised to the power? And it typically probably won't write it like this, putting the 2 itself in parentheses, but we just got to understand the only thing that's being raised to the power here is the 2, because we don't have those parentheses there. Okay, so real big difference between those two. Now, if I was to do one very similar, but this one is a little bit different because my exponent is a 3. Okay, so once again, you can use your calculator. The whole thing is inside the parentheses. So we're going to put that -6 in parentheses. We're going to raise it to the third power. Once again, it's -6 times -6 times -6. And that would give us a -216. If I do it like the one we did up above, and let's say I don't put the -6 in parentheses, then what's going to happen here is we still get a negative 216, okay? So in this one, I do actually get the same answer. And the reason why is because of my power. If my power is an odd number, 3, 5 would be the most common powers that you're going to see. Usually we won't go up to like a power of 7, so 3 or a 5. Then it really doesn't matter where that negative's at. It's going to end up being the same answer. So the ones that you really got to be careful of are the ones that have an even exponent. Okay, a 2, a 4, maybe a 6. 6 would be very uncommon for one that we would see. But 2 and 4, if you have an exponent that's even, that's when you got to really be careful of parentheses or not. If it's odd, not as big a deal. Over here, right? When I take the cube root of negative 216, it would get me back to negative 6. Okay? So over here, okay, just the opposite of that then is doing some roots. And we're going to look at some different types of roots here. We're going to do square roots, then we're going to do some cube roots, and we're going to talk about some of the differences of those. Okay, but first of all, one of the problems that you're going to see today is it's asking me to find all square roots. So whenever we see this word right here, all, find all square roots, what that means is anything that is a possible solution, okay? So if I gave you a number like 49, and I said find all square roots of 49. Really, what we can think of here is I want you to think of it as something like this. What number squared would give me 49? 7 is the easy one, right? 7 is the one, we take the square root of it, okay? And when we talk about square roots, we're looking for this symbol right here, okay? If you don't know where that's at in your calculator, try to look for it. You're going to use that a little bit today. But the key word here is all. So what numbers can I take times themselves gets me back to 49? Well, we already said 7 times 7. Is there anything else? Seven's it. Here's a hint. 7 is not the only answer. So what else maybe could we have? No takers? Yeah, negative 7, you bet, okay? So my answer here, what we would say is plus or minus 7, okay? Because 7 times 7, that was the easy one, right? That was the one we most of us got to. 7 times 7 is 49, no doubt about it. But if I take a negative 7 times a negative 7, what happens when I take a negative times a negative? It becomes positive, right? So negative times a negative would also work. So when it says find all, then we want to use this plus or minus sign on it, okay? If it doesn't have the word all in it, then the principal square root is all we're looking for, which is just 7. And that's the one we do a lot of times. But the word all in there is going to change things up a little bit. Okay. What if I ask you to do this one? Try putting this one in your calculator. If you don't have your calculator out, let's grab it out. And let's try putting this one into your calculator. That way you don't have to. Anybody need a calculator?
I mean,
Okay, everybody know where that button's at on their calculator? Everybody need help finding it? Square root? Okay, square root of negative 36. What happens when we type that in? It gives an error, okay? Why does that give us an error? Why does that not work? Because it's a negative. Absolutely, okay? There is no number that I can take times itself. Like up here, we said 7 times 7 is 49, right? But because negative 36 is a negative number, I can't do like 6 times 6. I can't do negative 6 times negative 6. And I can't do like one of each because squaring means you're taking the same number times itself. So you can't do like one negative and one positive. That's the only way to get to a negative number. So anytime you have a square root with a negative underneath it, then what we would say is there is no real number root. Okay, and it's kind of important to say it that way because in Algebra 2, and we're not doing this right now, and you guys will be glad, but we're not doing it right now, is we do have the imaginary numbers sitting out there, if you kind of remember that from Algebra 2. So I could take the square root of negative 36 if we were dealing with imaginary numbers, but in Chapter 1, we are not. In fact, in intermediate algebra, we don't get into imaginary numbers this semester. So you guys will probably be glad about that. Okay, but that's why I say there's no real number. In some cases, there could be a solution here if we were allowed to use imaginary numbers, but we are not doing that here. Okay. If it doesn't have the word all, then typically, in most cases, we are looking for what we call the principal square root, okay? And that's just the positive answer of the square root. So if I said, what's the principal square root of 64? We would just say 8. We're not going to put plus or minus on it. So the only time we have to worry about the plus or minus is when we have the word all, or if we're solving an equation. But we're not really solving equations today. So really you just have to kind of look for the wordings and the instructions. Does it want all, or does it just want, the principal square root is really just the positive square root. So you can kind of remember that word, or the letter P, principal means positive. So we're just looking for that positive root. Okay, and you're going to see some different variations. And some of these you're going to look at it and be like, oh man, that's going to be hard to do. Now there's no doubt you can use this and put it in the calculator, okay? But what I would tell you here is we've dealt with square roots before, and I would say you probably should know the first 10 perfect squares off the top of your head. At least recognize them. Because those are going to be the ones we're going to see the most. Most of you might know like 11, 12, and 13 also, but definitely the first 10 should be numbers that, boom, I know those immediately. We know that 1 squared is 1, 2 squared is 4, 3 squared, 4 squared. Those are numbers that when we see them, I know immediately those are perfect squares, right? And the reason why we should know those is because when I see a problem like this one that I just put up here, I notice that both of those numbers are perfect squares, right? 81 and 100 are both perfect squares. So the square root of 81 is 9. The square root of 100 is 10. That would be my answer. If you did this one in your calculator, probably more often than not, I would say most calculators are going to give you a decimal answer. It's not wrong to write this as 0.9, but I think this would be the quick and easy way to do it. Okay? And most of your calculators will change fractions to decimals and vice versa. Okay, we might see some decimals today as well. So like the square root of 0.09. That probably would be just a calculator problem. Here would kind of be the general rule that I would say. If the original problem is written as a fraction, I probably would say write your answer as a fraction. If your original problem has a decimal in it, then I would say probably write your answer as a decimal. Okay, that would be the general rule. It's not necessarily wrong if you write it in another format that's equivalent to it, but that would probably be the rule that I would kind of stick with. So if I take the square root of 0.09, what do I get? 0.3. Yeah. And we're still just looking for the principal square root, so that would be it. If I said the square root of negative 100, okay, do we even need to put that one into our calculator? Okay, first thing I should notice is we have a square root with a negative underneath it, and immediately it would be just like this one up here. We would say no real root. Okay, on all of these, if there is no root on the outside, all of these are assumed to be what we call a square root, and that there's an assumed 2 out there, okay? We don't put the 2 out there, but what we're basically saying is, if I said, what's the square root of 64? What number times itself 2 times gets me back to 64, okay? But now what we're going to look at are some other types of roots. Kind of goes back to what we talked about so now we're going to have to put the root up there at the top of the radical symbol. So we call this a cube root because we're doing 3. And we're going to do the cube root of 125. Okay, once again, make sure you locate this in your calculator. Most of your calculators have a cube root button. If you have a TI, like a graphing calculator, you'll have to go to Math, and then you can scroll down to the cube root button, and then you can type in the number 125. And what we're really saying is what number times itself 3 times gets me back to 125. Okay, and it would just be 5. 5 times 5 times 5 would give us 125. Okay, does anybody need help finding that cube root button? Everybody know where that's at on their calculator? Okay. Another one that we might see is the 4th root button. Most of your calculators probably don't have a 4th root button. So what you'll have to do is you find the button on your calculator that says X root. Some of the newer calculators will actually take the 4 and put it up here as the root. Some of it just leaves it out in front. But in most calculators, you have to put the 4 in first, and then put the X root, and then put 16. So once again, the question that we're really asking ourselves is what number times itself 4 times gets us to 16? And that would be 2. So the 4th root of 16 would be 2. Okay, now here's the part where you got to be a little bit careful. Okay, we're going to do one more here. Now we're going to do a 5th root. A 5th root would be put into our calculator very similar to the 4th root. Anything higher than 3, then usually we'll use that X root button. Some people will look at this and they'll say, oh, hey, we got a negative underneath the radical. That means we can't do it, right? But that only is true if this is an even number right here. This is not an even number. It's an odd number, okay? So we can have a negative underneath the radical. Kind of, if we type the 5th root of negative 243, make sure you notice that it's an odd number. What do we get? Or does it work? Should be negative 3. Okay. You guys, everybody okay with that? Everybody able to get that in their calculator all right? Okay. So probably wouldn't be a bad idea to always put it into your calculator, because what will happen in a lot of cases is a lot of people will see that negative underneath there and they'll be like, oh wait, we can't do that, only if it's an odd number, or only if it's an even number out here. So if this is a 2 or a 4, this number in here can't be negative. Okay? But if it's an odd number, we can do it. Okay, so a lot of those are real just kind of based on your calculator and being able to know how to put that into your calculator using the different roots and things. And I know this might seem like it's been a while since we've done this, and it kind of has, but not really, because we do this every single day when we do a math problem, okay? We have to do things in a specific order. And I'm going to kind of give you some harder ones here in just a second, just to kind of see where we land and if we can do them or not. Because if we don't do everything in the correct order, then it's going to be mass chaos, right? Everybody's going to get a different answer, and we're not going to know what the right answer is. That's why we must have the order of operations. We have to have a specific order to do things in, okay? You might have learned this different ways. I've always learned it as, please excuse my dear Aunt Sally, just an easy way to remember the order of the operations that we're going to do, okay? And some people don't necessarily like it that way because P stands for parentheses, but really what that is representing is any grouping symbol. So yes, parentheses are included in that. So obviously we would have parentheses. We might have some brackets. It would even include like absolute value. Absolute value is an actual operation, but can also be considered to be a grouping symbol because we would do everything inside of those symbols first, okay? So anytime you have symbols like one of those, we're going to do anything inside of that as our first step. When you learned that, maybe back in grade school or whenever you learned PEMDAS, we didn't have all these other symbols, and so that's why they use parentheses more than anything else, because that's the real common one. And we obviously will continue to see that here, but you will also see other grouping symbols. So we got to make sure we understand that it includes all grouping symbols. Okay, second thing that we talked about today is exponents. That's our second step. So we do all grouping symbols first. Exponents is our second step. Anytime we see an exponent, we've got to simplify that next. Okay, and even though this looks like it's 6 separate steps, it's really not 6 separate steps. These two happen at the same time. That's another reason why some people don't love PEMDAS, because you got to remember that when we go through the order of operations, all multiplication and division happens from left to right. If I had 6 times 2 divided by 4, I would do the multiplication first. 6 times 2 is 12. 12 divided by 4 would be 3. Okay? So we would do this part first, and then we would divide by 4. If I did 8 divided by 4 times 7, in this case, this would happen first, because from left to right, the division actually happens first. It's the first operation that shows up. So we would take 8 divided by 4, which is 2, and then we would take 2 times 7, which would be 14. Okay. And so a lot of people, especially when you're younger, probably when you see this, you always think, I'm going to do all multiplication first and then all division second, but that's not necessarily the case. Okay. So we got to do multiplication and division at the same time as I go from left to right, just like I read it, just like you would read a book. And then the last one is the same thing. We're going to do all addition and subtraction from left to right. Whatever operation comes first, we do that first. Okay, so let's practice the order of operations, okay? And I'm going to give you a couple of ones that there's a lot of stuff going on in here, okay? And here's what I'm going to do. I'm going to put up a problem, and I'm going to let you guys all in here try to work it out. Try to do it on your own. and let's see what we get, okay? So I'm gonna give you a couple minutes to work this one out. We'll do a couple of these. Go through the order of operations, and our goal is for everybody to get the same answer. And let's see what happens, yeah. Yeah. So it wasn't like over the summer and then turned on, this was, you've been using it already. Yeah, it was working after using it. Okay, let me, because, I don't know what's going on, because that's like, it's really weird that like, I've had 3 people ask me about that. And I don't really know what to do, I mean, originally we thought restart, but restart wasn't working for them either, so. What, let's see, what's kind of, I know it's TI, but.
I don't know, it's just minimal. That's what I do. Yeah, that's what I do.
No, for the whole thing. But this is all one problem. The lines in the middle are upside down.
Okay.
Good, yes.
It's okay. I know what I'll do.
Already past that. But it didn't say that.
I love being
What? Already past that negative 2.
and I just listen.
What are you talking about? This is negative 2. I know it's negative 1. I know it's negative 1. It's really, what are you?
I'll stop on it. And this was always comes out.
I know it's, you're stuck on the middle. Dude, put it in your calculator. That was the easiest. What am I putting in my calculator? Oh, they're not.
We're not sure.
They're 3 separate problems. They're really not. They're not. Those are parentheses.
So you do 5 minutes.
They really are. Because, see, look at P.
And then absolute value of -2 well, absolute value of -2 is
Hey, you're calling.
you have to keep absolute value.
Honestly, we already have.
Which is what the line for.
We're just adding together. We don't know. We don't know the next step. I don't know what you're used to.
I don't know.
Is this new? You got like a hundred. I got it. I was like, why they want to kiss me?
Because those don't have lines on either side. It has to be in the middle. It's like over here, it's 5, over here, it's 11.
One slip of it.
I don't know if I skipped anything.
Oh. Well, it's just about down.
I got this. So then my combined is lower than
Bro, did you slice every rival? Because I got 3 separate answers.
Yeah, he tried to mention the same. I took out
it actually is 3 separate. If it's 300, I still.
Why did you change that? I don't know.
No, I meant like after some.
What did you say? What did you say?
I would run.
I said 3 separate. I thought it was 1.
So a couple really cool. And then all my math lines in there, and then whenever these were needed for all the things, I have to like also.
Are you getting that together? It's just separating the question.
I don't think it is, dude. Maybe it is. Why do you have to stack them?
Ryan, you're doing great.
Well, we all got the same. You got one wrong, so yeah. Actually,
So even if it is 3 seconds, shoot 33%.
we shot 100%. He didn't actually listen.
I'll talk to you.
And we didn't crash out. And we didn't get the first question.
All right. You guys think you got it? Yep. 100% confidence, Zach? Without using any fancy apps or anything either, right? Just your head? Okay, let me see what we got here for answers. What do you get, Zach? Negative 18. Okay. Everybody agree with that? Everybody got negative 18?
No, I did. You only got 3 separate equations.
All right, what else did we get? Anything else?
I'm not.
I got negative 14.
Negative 14, okay.
Don't laugh.
Nope, not laughing, okay.
Oh, no.
What did you get, Eli? No, you didn't. That's not what your favorite is.
I got 110.
110, okay, yeah. All of those answers are quite a bit different, huh?
So at least like we're not the only ones.
Okay, who else wants to be brave enough to tell us what they got? You have an answer? You have negative 8, Eli? Negative 18? You sure you want to copy Zach?
That's probably right.
Do we have any different answers other than those 3? Did you get negative 15? Okay, any others? It's okay to be brave, because here's what I'll tell you. So far, I have not heard the right answer. Actually.
Come on,
Negative 10?
you say all 3. Maybe you'll get it right.
You got 3 different answers, Eli? You can only have one answer, man. There's not 3 answers.
He thought they were 3 different problems.
Oh, 3 different problems.
Currently got negative 36.
Negative 36, okay. Negative 8?
How many more answers can we get?
I know.
Technically, I got like negative 16, absolute value negative 2.
Hold on.
What?
Okay. Anybody else? Hey, so, and the reason I do this, yeah, there's a lot of stuff going on in this problem, right? And so it's really easy to not get the right answer. Because you've got to make sure that you do everything in the right order, and if not, then you don't get the right answer, right? And there's only one right answer, not 3, right? There's only going to be one, and we still don't have it yet.
Negative 110? I don't know. Good guess.
Okay, you guys ready to work through it? See what we get? A couple of the answers are really, really close. So there's probably just one little mistake in there. All right, where do you think we would start? Do we have some grouping symbols? Yeah, we got some grouping symbols, right? So in this case, we have a parenthesis inside of absolute value. So we got to do the parenthesis first, which would be 7. And then we got to do the 5 minus 7 inside the absolute value. And so this would become the absolute value of negative 2. Okay. Over here, Zach asked a good question. Can the square root symbol be a grouping symbol? Absolutely. Anytime you have some type of operation within some type of symbol, we can consider that to be a grouping symbol. So if you've got some operations going inside that square root, we would have to do that first. So I would go ahead and add the 16 and 9 together and get 25. Okay. That takes care of our grouping symbols. Okay, next step would be what? Exponents. Yep, we got one exponent. So negative 2 cubed would be negative 8. Okay, negative 2 times negative 2 times negative 2, so negative 8. Okay, now here's what I'll tell you. This isn't necessarily part of the process like PEMDAS, but if we have symbols that we have to simplify, that comes next before we do any multiplication or division. Okay, so we talked about absolute value, I think, in the very first lesson. If I were to take the absolute value of negative 2, what would I get? 2. Okay, so we're going to go from left to right here. We're going to go negative 8 minus 3, and that would become 2. I'm going to keep it in parentheses just to keep it as like a multiplication problem, minus the square root of 25, which is really 5. Okay. Next step is multiplication and division. Do we have any multiplication and division? Yeah. We got to do the 3 times the 2. So we're going to do negative 8 minus 6 minus 5. Okay, and then we're just going to go from left to right. Negative 8 minus 6 would be negative 14. And then we would do negative 14 minus 5, which gives us okay. Yeah, Majan?
The problem was the absolute values. I didn't know it was that. I didn't know that.
Yeah. Yeah, and I would agree with that. And here's a couple of things. And I'm sure we hadn't talked about that yet today. Absolute value definitely probably threw you guys off. Okay. Here's another thing with absolute value is you can't distribute that absolute value. You can't distribute this negative 3 through the absolute value. It's not a parenthesis. Okay. And that's another probably scenario that some of you might have tried is to try to distribute, but you can't do that here. Okay. So yeah, absolute value probably definitely was a big kicker there. It is a grouping symbol, but it's also an operation at the same time. Kind of like the square root symbol was. Okay, questions on that? So we were close, right? But I really kind of like to do that problem just mainly because everybody got a little bit different answer, right? And that shows you why the order of operations is so important, because we can get a lot of different answers if we do one little step wrong, and it throws us off. Okay, last one here. Let's try this one. Try simplifying this one. give you a little hint. I threw you another curveball here. Okay. Anybody think they got it?
Definitely did something wrong, but I got an answer.
What'd you get?
-72.
Okay, negative 72.
I agree with that. Board's error.
One of the two. Error or negative 72? About the same, right?
No, that's two answers. You can only have one.
You're making your own multiple choice test here, right? All right, here's what I'm going to show you real quick. I'm only going to focus on the bottom of this. Okay, watch what happens here. 2 plus 3 is 5. 5 squared is 25. So 5 plus 20 is 25. 25 minus 25 gives me 0 on bottom. I don't even really care what the top is. That's why I started with the bottom. Because what happens if I take anything divided by 0? You get an error. Okay? Try doing like 6 divided by 0 in your calculator. Watch what happens to your calculator. It'll say error or undefined or something along those lines. Okay? So I don't care what number's on top. The answer is no solution. Or undefined. Or a lot of different ways to say it. All right. Here's your assignment for today. You can take a quick picture of it if you need to, since I know we're running short on time. I'll also post it to Classroom as well, so it'll be on there. Tomorrow, if you have questions on any homework assignments, we can go over anything that you might have questions on. We'll work on the review. Quiz on Thursday.